everyone, welcome to my dining room. Today we are going to make my dining room into a science lab. We're going to do a lab together today. I'm going to model a lab for you. It is something that you can try at home if you would like, if you have the materials, or you can just watch me and follow along. At the end, we normally would do some sort of writing component, ticket out the door. You're going to actually do a discussion post on Canvas. So this activity is called the heart as a pump. Let's walk through it. So our key question is what happens during the pumping action of the heart? And our objective is to explore the working of the heart by making comparisons with the actions of a pump. We're going to build a model today. So if you've ever squeezed your hands together, have you guys done that in the water to shoot pool water at your family or your friends? Then you understand the basics of how your heart works. It's a muscle that squeezes together to pump blood around your body. But shooting pool water with your hands is pretty messy and splashy. Your heart has to be a lot more orderly. Wouldn't be good if our heart just splashed blood around in the empty cavity of our body. In fact, because of how your body uses blood, your heart needs to pump blood in just one direction. Blood carries oxygen in it, and all the parts of your body need oxygen to work right. If the blood pumped backward, your body would get that blood with no oxygen in it. So we don't want, once the heart has pushed the blood out, we don't want it to be able to fall back in, if you can kind of get the imagery of that. So in order to keep your blood flowing in the right direction, your heart has two pretty cool design features, chambers and valves. The chambers fill with blood and then squeeze tight to pump it out. Each side of your heart has an entry chamber called an atrium and an exit chamber called a ventricle. So your heart has 4 chambers total. The entry and exit chambers pump one after the other to push your blood forward. Each chamber also has an exit door called a valve. These keep blood from getting pumped backward. When the ventricle contracts, the atrium's exit valve closes so the blood won't push back into it. When the ventricle relaxes, its own exit valve closes to keep the blood from spilling backward into the chamber. That way, the pumping of each chamber moves your blood forward. It's always a forward motion. To see more about how the chambers and valves work, we're going to follow the simple instructions to build a model. So the materials that you need are simple. You may or may not have them around the house. You need a beaker or a cup, probably a cup. I doubt you have a science beaker at home. I'm just using a little plastic drinking cup I got in Nashville. It's nice to use one that has a lip on it because we're going to put a balloon on top. You do need balloons. These are just normal party balloons that I got from the dollar store that I had laying around the house. You need a skewer or a toothpick. Toothpick works fine. I just happen to have this, which is what we put our kebabs on, the skewer. Flexible drinking straws, so the ones that bend like this. You need scissors, and then you need something to catch the water in. I'm just using this baking pan that I have from my kitchen. So I've already done some of the steps just to save time and mess, but I filled my cup about half full with water, and I've cut my balloon. When you cut your balloon, what you're going to do is you're going to cut the neck of the balloon, which is the part you blow into. You're going to cut that off, and you're going to use this bottom part. This bottom part you're going to stretch. If you've ever worn a shower cap before or a swimming cap, you know you have to stretch it, and it's really tight, but you stretch it over. So you're going to stretch this over the top of the cup so that it's completely covered. Then with the skewer or toothpick, you're going to poke 2 small holes into that stretched over balloon. You want it to be about 2 centimeters apart. Now keep in mind that our pinky, here's a little fact for you, is about 1 centimeter wide. So about 2 pinkies worth, you're going to make holes in your balloon. Then you're going to carefully insert the straws into each of those holes that you poked with your toothpick or your skewer. The straws should fit snugly. Now it says in this PowerPoint to ask Miss Dollins for a new balloon if you struggle. I'm not there, I'm so sorry. It would be much more fun if we were all doing this together in class. It's a lot of laughs and the balloons go flying, and you know, it's fun doing labs. But I'm not there to help you, so you just have to say, you know, Mom or Dad, can you help me with this? Then you're going to use the neck, the part that you blow into, you're going to use this. This is going to be our heart valve. This you're going to actually put over your straw that's in the cup, and you're going to tape it down. And when you tape it, you want it to kind of hang down a little bit. So it looks like this. And you're going to bend the straw, and the other straw is going to stay up in place. Now, here comes the actual procedure, the experiment. So we're going to gently press in the center of the stretched balloon to watch what happens with the water or the blood inside of our heart. So this is our model heart that we've created. Now, take a moment and make a prediction right now. What do you think is going to happen? Is any water going to come out? Will water come out of both straws at the same time? Maybe there's a difference in timing. Will water come out one straw and not the other, or this one and not that one? What do you think is going to happen? Okay, so let's do this, right? Let's do this experiment and see what happens. Okay, so I'm going to press, and we're watching. Okay, did you see what happened? Okay, let's see what happens next. It says, take the balloon valve off the straw and pump water again. So I'm actually just going to replace this whole straw with another straw. Hopefully this works. Without a valve. So now this is without a valve. Do you want to make a prediction what you think is going to happen? Okay, here we go. Did you notice anything different? So, you made a single pump that moved water from the jar or the cup through the straws and into the pan. The cut end of the balloon worked as a valve to stop the water from going back down the straw. Once it got into the valve, once it got into here, it was pushed out completely. Your heart pumps blood through your body and your arteries in a similar way. The human heart has 4 separate chambers inside. This pump shows how one chamber and its valve works. A valve is used to keep blood that's been pumped from one chamber to another from flowing back into the chamber it came from. So try taking the balloon valve off the straw. We did that. Did you notice anything different? What you likely saw is that the water came right out and then back again. It came up and then it came down again. Without the valve, there was nothing to keep the water from going back down the straw. So in order to keep blood moving through your heart and into your body, your heart needs separate valves to separate its chambers. Conclusion. Do you know what makes the sound of your heartbeat? It isn't the heart muscles contracting. That's sort of a misconception that people think. Try flexing your biceps. Does that make a sound? It's actually the valves in your heart opening and closing. Just like we had this here, it's opening and closing to keep that blood from falling back in. The first sound from the valve between your atria and ventricles closing, and the second sound is the valve between your ventricles and the rest of your body closing. Doctors think these sounds go lub-dub, lub-dub, lub-dub. Do you think that's what the heartbeat sounds like? So this is going to be your discussion question for Canvas. Explain how the model we created today mimicked the way the chambers of the heart pump blood. So make sure you get into your discussion and answer that. I hope you actually tried to do this. It's messy, it's fun. I had to try it several times to make it work, to make sure I didn't get holes in my balloon or my balloon came off, but it is a lot of fun. So I do encourage you to try it at home. It's been nice doing science with you. I wish we were together. I hope you enjoyed this little experiment, and I hope to see you soon, even if it's virtually. Bye.